Now that you have your tools, you also need some basic materials. The most important material is your solder wire. I use lead-free wire which contains the necessary flux inside the wire. It has a tin content of 95.5%, silver content of 3.8% and a copper content of 0.7%. My preferred outer diameter of the solder wire is 0.5 millimeters. After you have joined two conductors by soldering, you must insulate the soldered joint with some heat shrink tubing. There are two basic types of heat shrink tubing. One is a plain type, the other one has an inner coating with hot melt glue. As a rule of thumb, I use the plain heat shrink tubing for all joints that are contained inside an outer encasement and not exposed to the outer environment. If the heat shrink tubing has to encase a number of already insulated joints and has direct exposure to the elements like ultraviolet sunlight, dust and moisture, then the heat shrink tubing should have an inner coating of hot melt glue. This will effectively seal the joint from entry of unwanted elements which may cause problems that are very hard to detect. It is very important to place the heat shrink tubing onto the conductor or cable before you start soldering your first joint. Nothing is worse than having to unsolder your joint just because you forgot the heat shrink tubing before you solder the joint. Okay, now that you've got your tools and materials, you are ready to solder your first joint. For that, grab yourself a piece of conductor. I use a conductor with 7 wires to the bundle, a 0.2 square millimeter wire cross section and a blue insulation. And because you want to document your work, here is how that looks as a wiring diagram. A conductor is represented by a line. Try to use a ruler when drawing a line. For identification, I write the color of the insulation, in this case blue, on top of the line. It makes reading a wire diagram a lot easier, especially when you try to read a large wire diagram like that of a wiring harness. Okay, let's start. Your conductor lies before you on your workbench. Pick up your wire stripper and adjust your backstop setting to 4 millimeters. To find the correct setting of your wire stripper dial, you need to do some test trips. Pick up the conductor and push its end against the backstop. Gently squeeze the grips together until the jaws close on the conductor. Keep squeezing, not too slow but not too fast. The cutting blade sink into the insulation, then draw it back away from the wire bundle. If at this point the knives don't tear away the insulation but instead scratch along it, you need to increase your dial setting. Turn the dial towards the plus symbol until you can hear and feel a clicking sound. Trim the conductor with your side cutter, then repeat the stripping process. If, on the other hand, the blades tear out one or more wires, your dial setting is too high and you need to turn it towards the minus symbol. Play around with the settings until the insulation comes off cleanly without tearing out any wires every time you try. Strip both ends of the conductor and lay aside the wire stripper. Get your soldering gear ready and place your third hand in front of you on the workbench. With one hand, pick up the conductor and hold it between thumb and forefinger, a few millimeters behind the stripped wire bundle. With the other hand, pinch the exposed wire bundle between thumb and forefinger. Gently twist the wire bundle a few times in one direction. Make sure you didn't miss a single wire or have the wires fray at the end. Clamp that end of the conductor a few millimeters back from the bare wires into one of the holding clamps. Take your soldering iron and clean the tip and apply some solder to it. Bring the solder iron tip to lay aside the wire bundle and apply some solder to the wire bundle. Be careful not to melt the insulation and minimize the time the solder iron is in contact with the wires. Once you have applied sufficient solder, pull away the soldering tip and the soldering wire at the same time. Lay both aside and remove the pre-soldered conductor end from the holding jaw. Now repeat this procedure with the other end of the conductor and place it into the other holding clamp. Hold it. What did you forget? Remember the heat shrink tubing? Cut off a short piece about 15 mm long from a length of 1.6 mm diameter plain heat shrink tubing. Release one end of the conductor from the holding clamp, push it through the heat shrink tubing and place it back into the holding clamp. Carefully align both pre-soldered wire bundles along each other. If necessary, use your tweezers to force unruly ends into position. They should run parallel to each other without a gap in between. Repeat the soldering process. Apply enough solder that both wire bundles are amply covered. Let the joint cool off before removing it from the jaws. The joint has solidified once the shiny surface of the solder becomes dull in appearance. Slide the heat shrink tubing over the joint until it is centrally located. Carefully apply heat with your heat gun with a waving motion of the heat gun nozzle. Congratulations, you have succeeded in making your first joint. But wait, don't forget your documentation. Grab a pen and some paper, ideally the 5 mm square type, and your ruler. Draw a square with an edge length of 20 mm or 4 squares. In the center of one line, draw a blob of about 2 mm diameter. Somewhere write the word blue above the line. The line is your conductor and the blob is your joint. This drawing represents what you have made. And hey, thanks for watching.